This is an example of Newton's law in one dimension. In the vertical direction, we've got a grocery bag. The maximum force that it can withstand without ripping is 235 newtons. That 19 kilogram bag of groceries is going to be lifted with an acceleration of 6 meters per second squared. Want to know if the bag will rip or not. Probably the easiest. There's a bunch of different ways to do this. That's what I love about this problem. But the easiest way to do this is probably to figure out what the force is that is generated by accelerating it at 6 meters per second squared, and then go ahead and comparing that to 235. If that force is greater than 235, then the bag will rip. So what we're going to do is we're going to figure out that force of lift. And if that force is greater than 235, the bag rips. If that force of lifting the bag is less than 235, then the bag survives. 2 R's in survive? I don't know. I don't care. All right, we're moving on. So here we go. We're going to do, obviously start with our force diagram. So I've got the bag, and there are two forces acting on the bag. There's the force of weight, and there's the force of the lift, lifting the bag. We are looking for the force of lift, so put a question mark there. Force of weight, we've got 19. You know what? I'm just going to calculate it. Forget it. I was going to say we got mass times acceleration due to gravity. So we've got 9.8, which is the acceleration due to gravity, times my 17. Whoops, backspace. 19 kilograms. So we've got 186.2 newtons for the weight. All right, so we've got our force diagram. Next step would be to rotate it if it's on a ramp. It's not, so we don't have to do that. Break any angled components, angled vectors into components. We don't have any angled vectors, so we don't have to do that. Evaluate the motion. We know that the bag is accelerating up because it's being lifted up with a acceleration of 6.0 meters per second squared. A little sidebar here. Velocity time graph, acceleration time graph. We know that this is moving up, which is, ground is going to be our reference point. So it's moving away, speeding up, because it's accelerating as it's being lifted up. So it's away, speeding up. So that looks like this. Let's do that in a different color so it shows better. Away, speeding up, so that's going to be a positive acceleration. And sure enough, we've got a positive acceleration there. All right, so we know it's accelerating. We've evaluated the motion. The next thing we do is sum of the forces. There really is no sense in doing anything in the x direction because there is nothing in the x direction. So we're going to go sum of the forces. We're going to take a look at the y direction. Sum of the forces is equal to the total of the forces. So I'm going to add up my two forces. I've got the force of the lift plus the force of weight. Since I have an acceleration, it's not going to be adding up to 0. It's going to be equal to ma. A little sidebar here. Remember, sum of the forces is also equal to net force. Net force is the same, it means the same thing as adding up all the forces. So it's the same as sum of the forces. So I can, if I've got, excuse me, if I've got something like this, I can either add up all the forces if I have force information, or F net can also be calculated through mass times acceleration. It really depends on what kind of information I have. And since they're equal, F net is both this and this, I can write that sum of the forces is equal to mass times acceleration. It's kind of a little substitution to get that going. So in this case, I've got some force data and I've got some acceleration data, so I'm just going to use this whole thing. All right. So let's go ahead and do that. Force lift, I don't know, plus force of gravity, or weight, is going to be a negative 186.2 newtons. The way I can tell that it's negative is that arrowhead is pointed downward. Is going to be equal to the mass, which is 19.0 kilograms, times acceleration, whoops, which I know I can put that in. So that is positive 6.0 meters per second squared. Great. So at this point, I've got force of lift is going to be equal to, let's go ahead and figure this out, 19 times 6 is equal to 114. So I've got 114 newtons plus, because I'm going to add this over to the other side, this 186. I'm going to add that to both sides to get rid of it and isolate the force of lift. So that's going to be plus 186.2 newtons, which gives me a grand total of 190, 200, 300.2. I'm going to check that with a calculator, but I'm pretty sure I'm right. 300.2 newtons. So there it is. It's plus 1886.2, enter. 300.2. Okay, I was right. So that force of the lift is greater than 235 newtons, so the bag rips and we get groceries all over the floor. All right. Again, there's other ways to do this. One of the other ways you could do this is to use this force maximum and figure out the maximum acceleration that the bag could withstand. You know what? I wonder if, how much time have I used? I could probably go ahead and do that. You know what? I could do that really quick. Let me slide down just a little bit. What you can do is say that, okay, I know that I can put 235 in for that lift force. That's the maximum force, lift force that can survive. Is going to be equal to 186 point, or excuse me, plus 186.2 newtons. Basically, I'm back at this force lift plus force of weight is equal to ma. That's going to be equal to the mass, 19 kilograms, times, this time I don't know a. Really what I'm looking at is if a is greater than 6, then, oh, what am I looking at? I'm not sure. Let me figure this out and then I'll tell you what I mean. But I know there's another way to do this. Try and do this fast. I should probably slow down a bit. All right, let me get the number and then we'll evaluate it. Oh, this is a negative 186. Whew. Yeah, all right, slow down. Don't make any mistakes. All right, so 235 minus 186.2, enter. That's 48.8. So 48.8 newtons is equal to 19 kilograms times acceleration. So acceleration is equal to 48.8 divided by 19, 2.56, 2.57. So 2.57. So that means that that's the maximum acceleration that this thing can withstand. Meters per second squared is max acceleration. So anything greater than that, if I try to accelerate the bag at a greater than 2.57 meters per second squared, it will tear. Our acceleration that we're given is 6 trying to let's do this. We're trying to accelerate the bag at 6.0 meters per second squared, so it is greater than 2.57. It will rip. Okay, and just another way to do this, another way to attack the problem. Either way is fine. Whichever way you feel more comfortable with. Again, I love this problem because there's a couple of ways to do it. It's awesome.